Hello everyone. Now today we will see the remaining topic from unit number 1, that is 2D and 3D rendering. So in our last lecture we have covered the topic that coordinate system and viewing transformation. In that viewing transformation we have seen what is the translation, scaling and the rotation regarding to the OpenGL. Now the next part is the projection transformation in OpenGL, right. So whatever we have seen from this last 2-3 lectures, that all are regarding to OpenGL. So now let us see what is the projection transformation. Before that, what is the projections that we will see? So we know that the objects are available in nature that are described in world coordinate, right. So but all the graphics display media are two dimensional. So what is this world coordinate? Whatever the objects we have in our day to day life, that all are 3D, right. So they are having their height, width and depth, everything. So these objects are having its original coordinate, that is world coordinate, but whatever graphics display devices we are using nowadays, that is a screen, monitor, printout, printer, etc. we want to draw that 3D object on the monitor, right. So what we are doing? We are converting that 3D coordinates into the 2D coordinates, that is we are converting the world coordinates into the screen coordinate, and for this we have to project that 3D object onto the 2D plane. Means whatever we are having on XYZ axis, that we are converting into only X and Y axis, because our screen is representing only 2D plane, that is X and Y axis. So we are converting them from 3D to 2D. So how we are converting that 3 dimensional to 2 dimensional? By using the projection. So projection is nothing but here the shadow of that object, right. So ideally, and projection is done or projected by projecting each of its point. So whatever object we are seeing, we are taking the only end points of that object to give the projection. We are not considering each and every pixel of that particular point, we are just considering the end points of that projection. Okay. So now we will see what are the different main coordinate system we are having. So first let us see what are the coordinate system. Up till now I have explained the two coordinate system like world coordinate and screen coordinate in last lecture, but from converting to world coordinate to screen coordinate, there are many coordinate systems that we have to see here. So what you have? First you are having your object coordinate, means object is having its own coordinate, right. So that I am converting into the world coordinate, means I am representing that object into the 3 dimensional plane, right, by using some modeling transform that I am doing first. So up till now I have told you that the world coordinate we are converting into screen coordinate, means from 3D I am converting it into 2D. But there are many coordinate system in between this that we have to learn. So how that world coordinates are converted? So first of all we are convert them into the I coordinate. I coordinate means whatever the coordinates which user can see. Okay, means if that object is placed in front of me, what are the part of that objects are seen to me? That coordinates are nothing but the I coordinates, and that can be converted by using the viewing transform. For example, we have seen in last lecture, that is translation, scaling, rotation, whatever. By applying that viewing transformation, we are converting them into the I coordinates. Okay. Then after that I coordinates, I will clip the portion which is not visible. Sometimes it may happen the back portion of that particular object is not seen, right. So we have to remove such a portion from that, that is called as a clipping concept. We are having a separate unit on that. Clipping, we are having a Sutherland-Cohen algorithm for clipping a particular object, that we are going to see in later units. But whenever we are converting our I coordinates into the clip coordinate, means only the portion we are clipping which are seen to the user, or we can see that portion we can apply on the screen. That all are done by using the projection transform. Now we have to learn here the projection transform, means only to project the part which is seen to the user, other parts we have to remove. So whatever the part of that object comes under the projection, that we are taking, that we are clipping, and the rest of the part we are removing, and this is all done through the viewport transform. For that we are applying some window on that part of between that window we have to take, and the part which is outside of that window that we have to discard. This is called as a viewport transform. This viewport is actual coordinate onto the screen, that is why it is giving you a device coordinate, or you can say the screen coordinates. So, by applying the last transformation, that is called as a viewport, then we are getting the device coordinate. So, up till now what we have seen, we are directly converting this world coordinate into this device coordinate, but there are many technique in between this, that is a viewing transform, projection transform and the viewport transform. So, we have seen the viewing transform, now we will see what is the projection transform here. So, this is what the example of that coordinate system. Suppose this is what a model you are having, right. So, this is 3D model. Then I want to represent this model with a world coordinate system. So, what I will do? I will project that onto the 3D system, right. So, I am representing that particular object in 3D system. So, you can see here the world coordinate, that object are shown with the XYZ axis. Then I have to convert that world coordinate into the I coordinate, means what user actually can see, that is nothing but a camera view. If you are taking a picture from a camera, so what is the position of camera, what is the position of that object, everything matters, and from that particular view what you can see from that object is nothing but a I coordinate. So, you can see here the camera view we are applying on this object, that is called as a I coordinate or a view coordinates. After that what I am doing, I am going to do, I will apply some projection on that, means which side of that object is visible, which side of that object is invisible, that we have to find out. So, we are applying some projection over here, right. So, by applying the projection I will get something, right, that I have to represent in the 2D. So, you can see this is what the 3D. Now, after projection what I have done, I have represented that particular object in 2D coordinate system. So, I am representing this. So, this object is look like this after projection on the 2D, right, and then from this which part we have to display onto the screen, that is decided by the viewport. Viewport is nothing but one window, the parts in between the viewport is visible, the part which is outside the viewport, that is invisible. So, applying the viewport on that particular object, now I am representing that object onto the screen, that is on a display device. So, this object will look like this by applying the viewport transformation. So, this is what the example of that coordinate system. So, now we will see what is the projection transformation. From that we have to see what is the projection transformation. So, we have seen the many terms, okay. So, I will give some short definition of that. The coordinates that you actually use for drawing your object is called as the object coordinates, means the coordinates of that object itself. Then the coordinates in which you build the complete scene are called as the world coordinates, means I am putting that object onto the 3D coordinate system, I am putting that scene onto the 3D coordinate system, that is called as a world coordinate. The next, the viewer is attached to their own individual coordinate system, right. So, which is known as a I coordinate. So, whatever I can see with my eyes, that I am putting onto one coordinate system, that is called as a individual coordinate system, that is called I coordinates. Then next, that OpenGL applies the coordinate transform that maps the view volume onto the cube, means I am converting that onto the 2D matrix by applying some clip coordinate projection, and after projection what I have get, that is called as a clip coordinates. So, this is done by applying some cube and that cube is centered to the origin of the system. Then after that at the end we are drawing the actual thing, right. So, they are called as a device coordinates, right. So, the 2D coordinate system in which the actual drawing taken place on the physical display device such as a computer screen. So, the best example of this what I can see, if I have one object, I am taking the picture of that object from a camera, right. So, object look like a different when I am seeing that object. If I am seeing that object by camera, so I am applying some projection of that object, means some part of that object we have to we are focusing on some part, we are neglecting some part of that object, anything. That means we are applying that object onto we are applying the projection on that object, and we are taking the picture of that object, right. So after that we are representing that object onto the screen, whether that a camera screen or you are having your desktop screen. So after that means your object is 3D and you are totally converting that object from 3D to 2D on your screen. So this is all done by this system, okay, that different coordinate system we are doing that. So after that we are resizing some part of that object, we are cropping something from that particular picture, we are focusing on some part of the picture, that is nothing but viewport we are applying on that picture. So this is all regarding the different coordinates and the different projection. So which different transform we can apply over here? So transform like a modeling transform, that is nothing but different size, orientation, the position of the object, everything matters over here. The next thing, the eye coordinates, right. So these eye coordinates are almost what you actually want to use for drawing that scene, means which part you have to take, which is we are going to neglect everything, that you are converting your world coordinate to the eye coordinate by using a transformation called as a weaving transformation. The next thing, you are converting your eye coordinates into the clip coordinates, that transformation is called as a projection transformation, and at the last you are converting that clip coordinate into the device coordinate, that is called as a viewport transformation, means you are representing xyz coordinate into the only x and y coordinate by applying a viewport. So this is a different transformation. So I am saying viewport, viewport, viewport. So what is this viewport exactly? So you can see in this example that this is what the world coordinate, right. So this is the image that you can see by your eye, okay. I have put that onto the clipping window, right. So this is a dotted square is showing a clipping window, this is what my object. So what I can see from this clipping window? Only the portion which is inside the window, this outside portion is invisible to me. So I will only take that portion from this clipping window, this portion is deleted, this portion is selected to view. So I will map that portion onto my screen. So this is what my screen, and whenever I am mapping that window coordinates into this screen coordinates, that is called as a viewport transformation, right. Viewport means only we can view that particular thing. So this is what the thing which we can see, and I am mapping that onto the screen, that is on xy axis. So this is called as a viewport transformation. Again one more thing I have explained here regarding the viewport transformation, that it transforms the x and y clip coordinates to the coordinate that are used on the display device, right. So I am converting them into the coordinates that are visible in display device. So to specify this viewport transform, we have only the necessary thing to specify is rectangle on the device with this scene will be rendered. This is done using this thing, means I have to find out or I have to show the viewport from which the scene will be rendered, only the scene in between that viewport is rendered. So what are the command for this viewport in OpenGL? So it is the command like GL viewport x comma y comma width comma height. So what is x is here, x and y are the lower left coordinate of that viewport, lower left corner of the viewport, means this part is showing the x and y, means here from here your viewport is starting up to this, up to what? So this is what the width, this is what the height, means from starting from this to this, then this is what the height. So here we are having our viewport. So what is the parameter x and y, that is its lower left corner points, this point, and then its width and height. So in this way I am showing my viewport onto the screen, means show that object on this portion of the screen, that xyz portion of the screen is called as a viewport. I want to show this part on this side of the screen. So that side is selected from this viewport. So this is what the example here. So this was showing x and y, this is showing your width, this is showing your height. So this is all about the viewport. Now this is a viewport transformation we have seen. Now we have to see what is the projection transformation, right? So I have said you that we are applying the projection. So we are not going to apply the projection on whole object, but we are applying that only on corner points of that object on the 2D plane, and for that we are having a two basic type of projection over here, right? So what are that? The first type is perspective projection and the second is orthogonal projection. These are the two basic types of the projection. Let's see them one by one. But before that, whenever we are activating the projection in OpenGL, which command we have to use? So whenever I am saying that I have to apply the projection in OpenGL, at that time I will use the command GL matrix mode GL projection. Okay, so this projection I am saying I am activating the projection over here. So the projection is represented in OpenGL as a matrix, in the form of matrix I am saying. So this is determined by the OpenGL state property called as a matrix mode. So for that purpose I am enabling my matrix mode with a projection, right? So the value of that matrix mode will be GL projection. Okay. So what I have to apply on the matrix mode? I have to apply the projection on that particular matrix mode. So first of all I will enable my matrix mode with projection, then I will apply the different projection. So let's start with the perspective projection. So perspective projection is more physically realistic. This is what the realistic means. Some part of object is visible, some are not visible, etc., etc. So these are called as a very realistic projection, that is a perspective. So in real world, the objects which are away from the viewer appear smaller, right? The objects which are away from the viewer, they are appear as a smaller. So perspective projection preserves this property, right? Means if we are away, then we will see the object small. If we are closer to the object, then we will see that object as a large. So this property is maintained in this projection. So the line of projections are not parallel over here. You can see that these lines, whatever are starting from the center of projection, they are not a parallel, right? They are not a parallel. All projection lines are ending at some single point. They are ending on a single point, that is called as a center of projection. That is nothing but you can say a human eye. Okay. So from our eye we are projecting some object. So our eye is here a center of projection. So you can see here we are drawing that image of an object onto the 2D plane. Means we have one object and we are going to representing that object onto the 2D plane. Actual the object is a 3D. We have to represent it on a 2D plane. So it shows the view that you could get by taking a picture of 3D world with the camera, right? So whatever we are using with the camera, that is called as a perspective projection we are using with our camera. So in this, the apparent size of an object is depends on how far it is away from the viewer. So only thing that are in a front of the viewer can be seen. Those means what the front thing of that object are seen to the viewer, back end things are not visible to that viewer. So here you can see from the center of projection you are projecting something from that window. Window is nothing but the camera is having some portion to view that object, that is called as a window, right? From that window what you can see, so you can project like this. From this window you are projecting the thing like this. Okay. So whatever the portions which are visible with this projection will display onto that particular screen. This is called as a perspective projection. We are having again different type of this perspective projection in upcoming units. In 3D transformation we are going to see that things, different projection, how we are applying that projection, which equations we have to apply, etc. things we are going to cover in upcoming lecture. So a perspective transform can be set up. So how we are enabling this mode? Means I have enabled the projection mode. Now which projection I have to enable? That perspective or orthogonal, that we have to see. So the command here is a GL frustum x mean, x max, y mean, y max, near and far. These are the parameters we are passing to the command like a GL frustum. So, here near and far are nothing but the two different distances from the viewer, whether the object is near or whether the object is far, that we are passing over here. And this x mean, y mean, x max, y max, all are the thing that are nothing but the sides of the means end points of that particular object, or a we can say a pyramid. Whatever the pyramids are founding due to this projection, that are nothing but the coordinates of its sides. Okay. So, this is what the thing I have called, or this is what the command I will call when I want to apply the perspective projection. If I am applying the orthogonal projection, orthogonal is also called as a parallel, because you can see all lines are parallel to each other. So, these projections are not like a center of projection, we are applying the different projection from the from this different window, and after that we are projecting that particular part onto the 2D plane. So, it is formed by extending the parallel line from each vertex. You can see here, from each vertex I am giving a line from each vertex of the object until they intersect to the plane of the screen, until they intersect onto the plane. So, you can see that the lines are projecting from here and it is intersecting to the particular plane, right, and the projections line are passing from that plane. So, this is what the view plane. So, you are putting that object onto the view plane, right. So, the point of intersection is the projection of vertex. So, what is the intersection point here? The vertex is intersection itself, and then we connect this projected line by the line segment, and we are representing that part onto the 2D plane, right. So, in orthographic projection, the 3D world is projected onto the 2D image. Means whenever we are taking the picture from the camera by using perspective projection, then they are represented on the screen by using this orthogonal projection, that is they are represented onto the 2D plane, right. So, this is what the concept of 2D plane. You can see here there are only the front and back of that particular object we can see, and that are projected onto this particular plane. So, in orthographic how we are enabling this projection, whether I have to select the perspective or orthographic. So, whenever I want to select an orthographic projection, I will call the command GL ortho. In that I have used the frustum, here I am using the GL ortho. Same parameter we have to pass x mean, x max, y mean, y max, and near and far. These are nothing but near and far distance of the viewer, and x and y coordinates are the left, right and bottom and top of the view volume. So, view volume we have seen in that this is what the view volume. So, we are giving x mean, y mean, x max, y max of this view volume over here. So, these are the command. So, what I want to conclude here is that as with GL frustum or GL ortho should be called when the matrix mode is set to be GL projection. Okay, means I will call this GL frustum or GL ortho only when I am saying my matrix mode is a GL projection. If I am setting my matrix mode to GL projection, then and then only we can call this GL ortho or GL frustum. So, GL frustum is for your perspective projection and GL ortho is for orthogonal projection. So, here we are done with 2D and 3D rendering of the objects in OpenGL. So, what we have seen in this rendering? We have seen the different transformation, that viewing transformation we have seen, then we have seen the viewport transformation as well, and we have seen the projection transformation also. So, here we are finishing that 2D and 3D rendering of the objects in the OpenGL. So, today we will stop here. Thank you all of you.